This is Maple-Lesson-02, and I am going to review lesson 1 and go over the homework. So let's take a look at some of the problems. Problem 1 was some arithmetic. So how to do very simple things. We want to add two numbers. And that's the sum. I want to subtract them, put in a minus sign. Again, sometimes in Maple, it's necessary to end the command with the semicolon. Most of the time it's not necessary. Sometimes it is. I often do it all the time just because it never hurts. But so multiply, the multiplication symbol is the asterisk, shift 8. And when you multiply these numbers, you get a big number. That's fine. And when you divide the numbers, let's see, I put in the slash, and I could just retype it if I wanted, but it's sort of an awkward way to do it. Anyway, those are the two numbers. When I divide, a fifth, wow. If I want the number as a decimal, I could either say eval f and type the number in again, or remember that a percent sign in Maple means the last thing I calculated. The last thing I calculated was this division, 1/5, and this will convert it to a decimal, EVALF, and then parenthesis, 0.2. Notice that if I put a space in between the F and the parenthesis, I don't get anything. It just doesn't work. Often you get an error. And when you're giving a command, you can't have unnecessary spaces between the command word and the parenthesis where you put in the argument. There can't be a space. So that's what we get. Problem 2 is to convert some numbers to decimals. The first is a complicated fraction, but it's just a fraction. 4 plus 6 divided by 7 plus 3 divided by 11 plus 1 divided by 8. As a fraction, that's what it is. To convert it to a decimal, Maple was case sensitive, so I have to write this in lowercase. That's what it is. And of course, I could have done it in one step. I could have just typed this fraction into here. And I get, of course, exactly the same result. It's just your choice. Square root, the two ways to write is to give the command for a square root in Maple. One is SQRT. So for the square root of 2 plus 13 divided by 5, well, I get this, but that's not really a decimal. So what I want is to evaluate this as a decimal, and that's what I get. I could also recall that a square root of a number is the number to the power 1/2. So I could write 2 plus 13 over 5, exponentiate, power 1/2. And I get it now in this form. Well, but I still want it as a decimal. And again, you see that this and this, they are exactly the same. Oh, back in problem 1, I left out one of the parts, which was to exponentiate. So if I take the number 387221 to exponentiate, I will raise it to the power 3. So I do shift and then the up arrow, which is the shift 6. And I put in my 3. So I'm going to cube this number, and that's what I get. Somewhat big number, but that's what it is. I like to save my work a lot, because if something happens and I lose it, I've lost a lot of time. I just have to redo it. So here I took this number and I was raising it to the power 1/2. If I want the cube root, I raise it to the power 1/3. I get an expression that looks like that. And to convert it to a decimal, that's what I get. Problem 3 is to graph some functions. So let me do this in a couple of different ways. The first is, let's say, if I want to plot the function minus 3x minus 5, the command is plot minus 3, I put in a times sign, times x minus 5, comma x. And so I'm plotting this with respect to the variable x. And the default in Maple is you plot from, it plots from minus 10 to plus 10. If you want to plot it over a different range, maybe minus 3 to 17. You go x equals minus 3, 2 dots, 17. And now this is going from minus 3 to 17. If I'm looking at the quadratic function, x squared minus 3x minus 5, I plot that, I get a parabola. Now, you'll notice that the x and the y axes have different units. So one unit, so for example, from here to here, that's 10 units horizontally. 10 units vertically is from here just up to there. Similarly, even when we're graphing these straight lines, this is the graph, x goes from minus 10 to 10, but this is going from about minus 35 to 25. So this is a correct graph, but it's not drawn to scale. If you want it drawn to scale, so 1 unit horizontally is the same length visually as 1 unit vertically, if you click on inside the graph, and I just did shift control, you get a little menu. One option is scaling constrained. If I click on that, now it gives me a graph of the function which is drawn to scale. So a horizontal unit is the same as a vertical unit. And this line you can see has slope minus 3, and it really is minus 3. If I take my parabola and I want to draw it to scale. That's what it looks like. It's very different. Let me actually let me make a note. So you can make a note by putting a sharp sign, and then this is with scaling constrained on. And this is with scaling constrained off. And it's generally up to you whether to use this feature or not. Sometimes it's useful, sometimes it's not useful. But if I asked you on an exam to use this command, to use scaling constrained, then that's what you have to do. Let's see. We had 2 more graphs to plot. One is this cubic polynomial. This is what it looks like. Let me graph it from -5 to 5. Oops, 2 dots. Yeah. Let me change it. Let me actually graph it from -3 to 3. And now you see the typical behavior of a cubic polynomial. If the leading coefficient is positive, comes up, has a local maximum, turns around, has a local minimum, and goes up again. That's the graph of this cubic. And the last is to look at this 4th degree polynomial. That's what it looks like. Notice how fast it grows up. It's like -10 to 10 horizontally, something close to 0 to 10,000 vertically. Let's see what's happening down around here. That's kind of interesting. If I graph this, let's say from -3 to 3, yeah, you see a little bit more clearly what's going on down there. Plotting is really important. It's an incredible feature of Maple, that a simple word plot will allow you to construct the graph of the thing. The next plot is a rational function. I put in a parenthesis so I can divide and get my denominator. Right? Well, this is x cubed minus 1 divided by x squared plus 1. Huh. So that's what this rational function looks like. I'm curious to see what's actually going on here. This is where it's sort of interesting. Maybe I'll graph it from -2 to 2. Yeah, it's kind of nice. Now, what you learn in calculus is that this function is very close to just x cubed over x squared, or x. So even though this is more complicated than just the function y equals x, it doesn't differ very much. In Maple, if you want to graph 2 different functions on the same plot, you just you put the functions you want to plot together inside a curly bracket. So separated by a comma. So if you look at what I did here, this is my original rational function, comma x. That means when I graph this, I'm going to graph these two functions together on the same plot. And here they are. Maple puts them in different colors. So you can see the blue is this rational function. The red is the straight line, y equals x. And we get very close together. If I plot this, let's say, from minus 100 to plus 100, you can't even tell them apart. These functions are so close together. And so here, just from minus 5 to 5, they're pretty different around here. It's not clear exactly on this small graph what's going on. But when I looked at the same plot from minus 100 to plus 100, they're almost identical. So that shows you visually that the function x cubed minus 1 over x squared plus 1 is very close to just the function x. Okay. Well, Maple can do a lot more than plot polynomials and rational functions. It'll plot anything. So the next example is a trigonometric function. I want to plot sine of 2 times x, put in the multiplication sign, plus 3 times the cosine of x. And that's what the graph looks like. You'll notice when Maple plots a trigonometric function, the default, instead of from minus 10 to 10, is from minus 2 pi to plus 2 pi. And if you want to see it over a longer interval of x, you just put in what you want. So maybe minus 6 times pi. When you write pi in Maple, you must use a capital letter P. So minus 6 pi to plus 6 pi. And there, that's what it looks like. You really see the periodicity of the sine and the cosine. They have period, they repeat every 2 pi. The next problem is the exponential function. To write e to the x, you do not write the letter e, you write exp. This means the exponential function. And what we're exponentiating is x squared. That's what the plot looks like. Unfortunately, it's like shooting up really fast. It's like 10 to the 39th in this small range. So you can't see very well what's going on. If you want to see, it's restricted, let's say, to minus 3 to 3. See again, see how fast it goes up? Maybe minus 2 to 2. Now, this graph is not wrong. It's absolutely correct. This is what the graph of the function looked like. It's just that this grows so fast that it's like shooting up to infinity. And that's what it looks like. It's actually more interesting, perhaps, if you study statistics, is the function e to the minus x squared. This gives you the famous bell-shaped curve. That's e to the minus x squared. And the last thing we are asked to plot is the arc tangent of x. That's what it looks like. Right. Make this a little bit wider. That's what it looks like. That's the arctangent. Problem 4 is to solve some equations. So if I write solve the equation 3 times x plus 5 equals 0, comma x, solve for x, I get minus 5/3. To get the solution as a decimal, the simplest thing is to use a different command, fsolve. The F stands for find the solution as a decimal, and that's where it is. There's one solution. How do we know there's one solution? Because if I plot 3x plus 5, the graph crosses the x-axis at just one place. That's the root of the equation. That's the solution. Let's look at the quadratic equation. X squared minus 3x plus 5 equals 0. If I don't use fsolve, if I just use solve, I get, this is the exact solution. I, the square root of minus 1, this says that the only solution of this equation is 2 complex numbers. In high school, they tell you that means there's no solution, but if you try fsolve, this is just looking for real solutions, and there aren't any. And if you want to know why there aren't any, if you plot the graph of this quadratic equation with respect to x, it doesn't look like the parabola crosses the x-axis at all. You have to sort of stare pretty hard here to see what's going on, and maybe if we just want to magnify this, suppose we just graph this, say, from x going from -1 to 4. Well, if you know, so here you have to be a little bit clever. If you look at the y-axis, it's not going down to 0. So this really is way above the x-axis. Just to, as I graph the constant function 0 along with this. So now you can see this parabola doesn't come close to the x-axis. So when we fsolve, we got no solution, and we got no solution because there is no real solution. If I make this the cubic polynomial, there's one solution that we see. Let's plot this. Well, it's not clear what's going on. I mean, it crosses the x-axis at least once. Let's blow this up a little bit. Let's graph this from x going from -3 to +3. So now we see exactly this cubic really does cross the x-axis in just one place, and the place is at -2.2. Sometimes Maple doesn't give all solutions of an equation immediately, and you have to be a little bit clever, force it to find other solutions. As we will see it several times in the class. Here's a 4th degree polynomial. I tried to fsolve it, I got no solution. If I use solve, I get so this is completely correct, but it doesn't mean anything to you. This is just saying something about the fact that there are no real solutions. And let's just take a look at the graph of this. Let's plot this fourth degree polynomial. Get rid of that. Huh. It looks like it doesn't come close to the x-axis. It doesn't cross the x-axis. Let's see, let's blow this up a little bit. Let's graph this from maybe -2 to 2. Again, it's not coming down to 0. Let me plug in the 0 just to, actually. I can also give a range of values for y. Y goes from, let's say, -1 to 25. Let's see what happens. Yeah. So you can see this fourth degree polynomial never hits the y-axis, never hits the x-axis, so it has no solutions. Let's go back. So this is problem 5 now. Let me save. It's important to save as much as possible, just in case I don't lose it. So I don't lose it. I want to look at the graph of the cubic. Again. And it says, plot the graph of this cubic and find graphically where the curve crosses the x-axis. So I'd like to find this to a certain number of decimal places. Now I did find this using the solve command. Here the point is that by blowing up the graph around this point, you can actually get the solution of this equation to many decimal digits of accuracy. What do I mean by blowing it up? Suppose I graph this maybe just from -3 to 2. Huh, that's what it looks like. Let me graph it from maybe -2.5. Oops. What I meant here was -3 to -2. Yeah. So I can see that this curve, I'm looking at this point, it really is crossing the x-axis in this interval. So let me try and get a little bit more precisely. I'll graph it from -2.4 to -2.2. So that same point, it's like it's between -2.3 and 2.25. Maybe I'll graph it again from -2.29 to -2.27. So you can see it's getting very close to -2.80. Let me graph it from -2.8 to -2.2. This is 2.280, 2.278. Let's try that. So you can see it's really close to -2.279. What I'm doing is I'm just magnifying the graph around this point and solving the equation graphically in that way. And I already solved it exactly using fsolve, but I'm just asking problem 6 to do it again. And this is fsolve the equation. X cubed minus 3 times x plus 5 equals 0 for x. And I get -2.279. I get exactly that. Exactly that. Okay, so that's the homework. And again, let me save it. This is saving it as a worksheet. But I also want to save it as a PDF file. So I go to File, Print, go to PDF on the print menu, click on PDF, and what I want to do is save as PDF. So save as PDF, and this is Maple-Lesson-02. Save it, and I'm done. And that is the end of our lesson.